Another type of transformation that happens when we multiply the x values in the function. Not the whole function, but just the x values by a number. So what if we just, inside of the function, multiplied x by some number b? Of course, we know that if b is 1, which it is right here, there's no change in the graph. But if I let b bigger than 1, b bigger than 1, then the graph gets narrow again. The only difference is that this is actually, we call this type of, we don't call this a vertical stretch. We call this a horizontal compression. So it looks like a vertical stretch and it can be confusing. But just for the sake of you understanding the notation, whenever b is bigger than, and let me go ahead and try that. Whenever b is bigger than 1, we're going to call that a horizontal, because it's happening from x probably. Horizontal, and we call this a horizontal compression. It's like someone squeezing it from the sides, and so that's why it gets skinnier. All right. So, and same thing happens if I let b be equal to, let's say, 1/2 or 0.5. I'll put that in there, 0.5. Then we get the same. We get a horizontal stretch now. So when b is between, and let's see, I keep wanting to do that for some reason. When b is between 0 and 1, you're going to have a horizontal stretch. Horizontal stretch, like someone's pulling it from the sides, which looks just like a vertical compression. I know it's confusing. Okay. Now, of course, b can be negative. Let's see what happens when b is negative. When b is negative, and let's see, in this particular example, it may be hard to see. So what if I just let b be -1 and I hit enter? Okay, you can't really tell. It looks the same, and that has to do with the fact that we're using the absolute value function, which essentially gets rid of the negative function. So I have to maybe use a different example to show what happens when b is negative. Use a different type of function, because you can't tell it with this function. Okay, so there might be a separate video. Okay, and so we only, now that's 3, so we got those. But what's supposed to happen, what you don't see at this graph, is that when b is negative, and I'll go ahead and at least tell you this, when b is negative, or when there's a negative sign on the b, I'm going to say when b is less than 0, or the negative sign of it, you have a reflection again, but this time, and because you can't see it in this graph, reflection about, this time, the y-axis. And that's because this graph is symmetric, you can't tell. If I get a graph that is not symmetric, you can see this, but because the graph is symmetric, you can't see.